Hello everyone, my name is Finding Pepper and welcome to episode 3 of the Perlin Noise Terrain Generation series. This episode is a little bit weird because we're going to start by building off things we created solely in part 1, and then later in the second half of the video, I'll combine that stuff with the stuff we made in episode 2, which was our 3D rendering of the terrain. I'll start by adding layered noise, which is multiple layers of noise which make more detailed terrain, and seeds, which are essentially codes to tell the program what to generate. So if you input the same seed multiple times, you'll get the same world. And if you're doing the 3D Minecraft series, you'll need all of that for the video in which I code Minecraft terrain generation. Now the second half of the video, I will build on part 2, which is our 3D renderer, and I will combine that with our seeds and layered noise, and I will finish off by having larger worlds which we can move around and load more chunks without having to render the entire world all at once. Alright, without further ado, let's get started. So hopefully you have your project from part 1 saved. Anyway, let's go to File and Save as a copy to get a new project. Let's run our project just to refresh ourselves on how it works. Remember to enable turbo mode, and we can see that our terrain is being generated. Now it looks decent, however it's not very detailed. For example, the coasts are super smooth and they don't look all too natural. So how can we fix this? Well, rather than just doing one layer of noise, we can add more layers of noise on top of it. Each of these new layers will be twice as detailed as the previous layer, so that means the grid will be twice the size, but condensed into the same space, and its height will be added to the previous layer's height, but the effect of the new layer will only be half that of the previous layer. Now let's make a variable to hold how many layers we have. I'll call it num layers for the sprite only. When the flag is clicked, I'll set that to, say, 3. Now let's edit our make gradients block to include the new layers. We'll just tack the gradients for these new layers onto the end of the previous gradient lists. I'll make a variable called layer to hold what layer we're currently on in any loops we might want to use. How about the top of make gradient? I'll set layer to 1. Now because each of the layers are double in size, I'm going to double the layer variable for each new layer rather than just adding 1. So the first layer will be layer 1. The second will be layer 2, but then the third will be layer 4, and then the fourth will be layer 8. Now around this repeat loop, we're going to repeat num layers. And inside the loop, we'll set layer to layer times 2, just like we talked about. So doubling the layer variable each time. Remember, our grid will get bigger on each layer, so we can multiply the grid size variables here by our layer variable. So the grid size effectively increases on each layer. We don't need to change the gradient generation at all, we still want random gradients. If we run this right now, everything should behave exactly the same. And yes, it is, so that's good. Alright, now we need to update our find point height block. Now rather than finding the point height just once, we're going to need to do it multiple times for each of the layers of noise. Then we'll add the heights together at the end. So I'm going to separate off the code here and put it into a new block called find point height at layer. Run without screen refresh. Now in our find point height block, I'll duplicate this loop from our make gradients block, delete the inside, so we're just setting layer to 1, repeating num layers, and doubling the layer variable each time. Now in this block, we'll use our find point height at layer block. At the beginning, we'll set our height to 0, and then if we go into our find point height at layer block, down at the bottom, rather than setting height, we will change height. So our final height is a sum of the heights of each of the layers. However, we do need to remember to divide this height by our layer variable, so future layers have less effect. Now to double the size of our layers, we'll need to multiply our x and y values by layer. This is because the points where our gradients are all at integer coordinates, and every integer coordinate has a gradient. So when we scale the size of the grid cells down, our x and y coordinates have to be doubled to compensate for the fact that our coordinate system is being scaled down. So we multiply x and y by layer when we set base x, base y, cell x, and cell y. However, we're not changing our code to reflect the fact that we should be accessing later items in the gradient list on later layers. So let's do that now. I'll make a variable to hold the index of the first gradient on the layer we're currently at. I'll call it first IDX. In find point height, I'll start by setting first IDX to 1, because remember, lists start at 1. Then in our subsequent layers, we're going to change first index, and then we can just duplicate this item in the repeat loop of make gradients, because this is how many items each layer has in the gradient lists. So I'll put that here. Make sure to do this before you set your layer variable. Alright, now let's use our first index variable in find point height at layer. So we'll replace these ones that we add to base x with first IDX. Now here we add 2, so we need to replace this with a plus 1, a base x plus 1, plus first index. Then the same down here. Then for these are just plus 1, so we can just use our first index variable. And then these down here, we'll need to use our base index plus 1 plus first index. Now if we run this, now we have our world generating. And yes, you can definitely see it's more detailed. We still have our basic terrain shapes we had before, but now the coastlines have more variation. Now you might have seen in my examples that I had contour lines. So let's just add those. I think they make the terrain look a bit nicer. In draw world, get an if else surrounding the set pin color things. Put what we have in the else, stick this back here. Then we can check if height is close to a multiple of 0.1. How we'll do this is with modulo. We need to round the height variable because the height often has a lot of decimal places after it. However, we don't just want to plain round it because it's always between -1 and 1. So let's multiply it by 100. So now we can get a nice number between -100 and 100. Then we can simply modulo by 10. That's equivalent to dividing by 10 and getting the remainder. So then if round height times 100 is divisible by 10, then we'll set pen color to black, meaning we should draw a contour line. And now you'll see contoured lines appear on our terrain. Now they're certainly not perfect lines. However, I think they do the job pretty well. Just for fun, let's try turning our layers up more, maybe to 4. Quite detailed indeed. If we decrease the grid size, we might be able to appreciate the detail a little bit more. Let's turn it down to say 4. Yeah, that looks nice. Alright, now I'll reset these variables. You can mess around with them more if you like, but I'll just set grid size back to 7. And it's now time for the next thing, which is arguably more exciting, and that is seeds. Seeds are a number that we input, and then it will generate our world based on that number, using something called pseudo-random number generation. So if we input the same number multiple times, we will get the same world each of those times. But if we input a different number, we should get a different world. Let's briefly talk about the pseudo-random number generator we'll be using and how it works. To get our pseudo-random numbers, we'll be using an algorithm called a linear congruential generator. This is a very simple type of pseudo-random number generator. We start with a number called the seed, and we want to make sure that when the seed is the same, the random numbers generated are also the same. So we'll perform a specific operation on our seed to create a pseudo-random number. You might think that, well, then we can only have one pseudo-random number, but that is not the case, because we can perform this operation again on that number generated to get a new number. And we can repeat this over and over again and get a sequence of pseudo-random numbers as long as we like. So you might be wondering what this operation is, and it is really quite simple. Here it is, and this might look a little bit complicated, but bear with me while I explain it. So you'll notice we have two x's. One has a subscript of n plus 1, and one has a subscript of n. So x sub n is the previous number, and x sub n plus 1 is the new number we're generating. So you can see that we are in fact generating our new number based on our previous number. Now you might be wondering about a, c, and m. Those are simply constants. They can be anything we want. However, there are some numbers that work better than others. I've taken one such number from the Wikipedia page on LCGs, and that is the numbers displayed here. I won't bother reading them out. And so the formula is a times our previous number plus c, and then we modulo that whole thing by a number m to get our new number. Okay, cool. So now that we know how LCGs work, let's implement them in code. The only random thing we have here right now is our gradients. So we know we need to generate random numbers for these. And this works pretty well because these are in sequence. They're in a loop. They fill into a list. So we can just use our pseudo-random number generator to generate a series of numbers for each of the items in this list, and use that to pick the direction of our gradient. Alright, let's make a variable called seed, and I'm going to make this one for all sprites. That's the only one like that. All the other ones are for this sprite only. When the flag is clicked, let's ask the user to input a seed. I'll ask enter seed, and then we can set seed to answer. To make sure it's a number and an integer, let's round this. We don't want any weirdness creeping in. Alright, now we'll make a variable to hold the current number we're on. I'll call it RNG for random number generator. At the top of my gradients, I'll set this to our seed, so that's the first number in our sequence. Then for each gradient, I'll increase the number in the sequence. So set RNG to, and then here comes the big bad formula with lots of large numbers. RNG times, then a plus, and then a mod around this. I'll stick this in the set RNG. For the first number, that's in the times. That is 429496729 plus 166452 modulo 101390422 Also, make sure you've inputted these correctly. It's not the end of the world if you don't. It just might make slightly less nice terrain. Alright, now we can use this number. We want a number between 0 and 360, so let's get a modulo RNG by 360 and replace our dir with this. So that's what we're adding to our lists. Then we can get rid of the dir variable, get rid of it entirely in fact, and now let's run the project. We get an enter seed. I'm just going to type the seed 0, and here we go. And if you use the same numbers that I did, you should have the same terrain. Awesome, that's looking lovely. Let's real quick just try entering that again, just to make sure we got the same thing. Yes, indeed we do. Let's try another seed, like 1, 2, 3, 4, 5. And there we go, there's our world. This is already looking so much nicer than it did just a little while ago. Alright, so we have our world, but if we wanted to make this any bigger, it would be kind of hard to make out the little details. And even from this scale, we might want to be able to zoom in on the map and move around. So let's go ahead and add that. I'll make some variables, chunk x and chunk y for all sprites. Now you might be wondering why I'm calling them chunk x and chunk y. You'll understand that more later, when we get to the 3D section of this video. Anyways, let's set these to 0 when the flag is clicked. Now let's get some simple key presses to detect changes in this. So when right arrow key pressed, we will change chunk x by 1 and then draw world. Similarly, when our left arrow is pressed, we'll change it by -1. Then when up, that's for our chunk y, and down arrow, changing chunk y by -1. Now in draw world, rather than setting x and y to 0 here, we'll set them to our chunk variables. So set x to chunk x and set y to chunk y. Now when we change x and y, let's change this by, say, 0.005. And same for the y. Now if we run this, you can see now we're generating only a small section of our world. Let's press the right arrow key, and then we move a little bit. You'll notice there are some lines here, and that is because we moved our camera before we finished drawing the world. So rather than using our draw world block here, I'll put these in a broadcast. So I'll broadcast a message draw world, and then when I receive draw world, we use our draw world block. And then same here, replace all the draw world blocks with the draw world messages. And then we can put a stop other scripts in sprite before we draw world, so it makes sure to stop the code that was previously running and start over again. So let's try out that And then now if we move to the right, you'll see we don't have any of those lines. Now this is pretty slow. So one solution to that would just be to be changing x and y by 2, say, then looping for less time. I'll say 180 and 240. We also need to change the pen size, set pen size to 2. Yeah, there we go. And that works pretty well. Now because we're changing by a smaller amount, we might want to change our x and y variables by a larger amount. I'll change by 0.01 rather than 0.005. Yeah, and there you go. But of course you can mess around with this. Now real quick, let's try going down a long ways, and you'll notice that in these negative chunks our terrain looks a little weird, and this is because we are out of the range of our grid. So here only the most detailed layers being drawn. There's also like repetitions and stuff, so let's just prevent this from being seen. Around everything here, I'll take out this if and the find point height, and around this I'll get an if else. And stick this back where it was. And here we're going to check simply if x is less than 0 or x is greater than grid size. And then same for the y. Y is less than 0 or y is greater than grid size. If this is the case, let's just set our pen color to black so we won't draw anything off the world. Let's just put in our seed, and then when we move off the screen, you'll see that we are not drawing anything over there. And now we can actually set our grid size to be larger. We'll set it to 48, and now our gradient list has 195,000 items in it. And I've chosen 48 because if we set it to 50 and run this, yes, it hits the scratch list limit, which is 200,000. So let's set it to 48. We can bypass the limit though by going into Turbo Warp. So I'll save this to my computer and then grab it in Turbo Warp. Now if we set grid size to 50, make sure to turn on turbo mode, and yeah, there we go. It can bypass the list limit, and also it generates so much faster. Yeah, this is really nice. Alright, now I did say that I would do infinite generation. However, I've decided to not do that and instead do some improvements to our 3D renderer, adding to it our layered noise that we've created and our scrolling and our seeds. Alright, let's go ahead and put some of the code that we're going to need for our 3D project into our backpack here. I'll start by dragging the when flag clicked, then make gradients, but I'm not going to include the hot block. I'm just going to drag the code inside of it. And then the same with our find point height. I'm just going to drag the code inside of it. Now we're going to get our find point height at layer block with the hat block. And yeah, that'll be it. So let's head over to our 3D project. Okay, here we are. Delete the contents of the find point height block and then replace it with our new code here. Then I'm going to drag out the find point height at layer block. Now I'm going to delete the contents of the make gradients block and replace it with our new code that involves the seed. And yes, we can delete the dir variable. Now I'll drag out the flag code. Over, we'll just take everything down here. So set num layers, chunk x, chunk y, and the seed. Then we'll just plop it right here. Alright, let's real quick try running this. See what happens. Aha! Well, we do have a world. However, it's not very smooth. The terrain is super undetailed. Plus there's some gaps in the terrain here that we can see through. We can make this better by increasing our detail variable. I'll bring it up to like 100. And then that's going to make this pretty laggy, so I'll decrease the lattice count to say 3. And there we go. So this is looking a little bit better, but still the terrain is super tall. So let's go ahead and make it less tall. In Draw Terrain, when we set transformed positions to, based on the height of our terrain, I'm going to divide the height times detail part by num layers. So the more layers we have, each of those layers are going to contribute to the final height, so we should divide the height. And then now we have much more flat terrain. You know, this might be a little bit too flat for your liking. Yeah, already looking pretty good. We got all of our layer stuff right into our 3D project in no time at all. Alright, it's time for our next thing then. Let's go ahead and try setting the lattice count to something like 7. And yes, this is super laggy, and it is not very pleasant to play. So what if we want big worlds, but no lag? Well, we don't really need to be rendering this entire thing all at once. We could just be doing the part of it that we're on. So that means dividing the world up into chunks, and only rendering the chunks around where the camera is. Alright, so we got our chunk X and chunk Y variables. Now I'm going to rename the chunk Y to chunk Z, because we're in 3 dimensions. And let's convert these other variables we have to for the sprite only. So our only for all sprites variables are chunk X, chunk Z, and seed. Let's make one more variable called chunk size for all sprites, which will hold how big our chunks are. I'm going to set chunk size to say 150. So we're going to have a 3x3 area of chunks loaded at a time. 1 is where the camera is, and the other 8 are the chunks surrounding the chunk where the camera is. So that means that the size of the loaded grid will now, rather than being lattice count minus 1 times detail, it will be chunk size times 3. Okay, now we can go into our create height map block. Now real quick, actually before we do this, I'm going to edit the find point height block to include inputs X and Y. And then same for the find point height at layer block. Then to our call of the find point height at layer block, we can pass in X and Y. Except you'll notice that here in find point height at layer, all the times we're using them, we're multiplying them by the layer variable. So rather than just doing plain old X and Y, we'll do X times layer and Y times layer. Then in find point height at layer, we'll replace these X times layer with X, Y times layer with Y, etc. Just in these 4 places. That's all the times we reference X and Y. Now that's not super necessary now, but we might need to use this find point height block for something else later. Plus it allows us to use our Z variables instead of the Y variable, and that is more intuitive because it better represents what 3-dimensional axis we're representing with those variables. So as input to find point height, I'll put in X and Z. Alright, now the one thing we need to change about this block is what we set Z to. Well, obviously we need to do it based on chunk Z. When we're in a different chunk, we're going to be looking at a different part of our world. Then let's multiply this by chunk size and then divide it by detail. So multiplying it by chunk size is going to convert it to our coordinates that we use to access data in the heights list, and then dividing it by detail is going to convert it to the coordinate system that we use to get our point height. And then we're going to do the same thing with our X, just replacing chunk Z with chunk X. Now this is still actually going to be pretty laggy, so I'm going to change the number of layers down to 3, the chunk size down to... So now I'm going to run this. Yes, here we go, that's much better, and now we only have a small area of the map. Now let's get on to moving to other areas of the map. So what will want to happen is, say when we move too close to the edge into a new chunk, we'll want to deload the stuff behind us and load some new chunks. So let's make a block to test when we enter or leave a chunk. I'll call it check chunk load. Run with that screen refresh, and I'll stick it after we move camera. Now when we load new chunks, rather than moving the world to be underneath the camera, we're going to be moving the camera back and just changing what terrain is in the same space. So it will give the appearance that we're going into a new area, but really we're just in the same area with different terrain. So with this we can simply check. We'll start with camera X. If camera X is less than chunk size, so if we get out of our chunk in the negative X direction, we'll need to move one chunk in the negative X direction. So change chunk X by -1. And then we'll need to loop our camera back around. So change camera X by chunk size. Then we can use our create height map block to regenerate our world. Now in the else, let's do if camera X is greater than chunk size times 2. So if we're out of our chunk in the positive X direction, then we'll change chunk X by 1 and change camera X by negative chunk size. Let's do this same thing for the Z, replacing all the camera X with camera Z and all the chunk X with chunk Z. And we can make the last one just a plain old if. So if we run this now and try moving off this way. And yep, there we go, we have new chunks getting generated. And the old ones get unloaded. This is awesome. Now we can do a little bit of cleanup in our draw terrain block. Well, with our new system, we'll never be off of the edge of the terrain. We can always just set index to camera x, because camera x will never be less than 0 or greater than grid size -1. And same for end z. But because these are just representing camera x and camera z, we can actually just remove these variables entirely and replace all our end z variables with camera z and all of our end x variables with camera x. And there's actually only one of these in each of the cases. So running that, everything should work the same. It does appear to work the same. Wonderful. And then I'm going to address one more thing with the loopter variables that's been bugging me. Well, when I'm changing x and z, I change my negative this, which just doesn't make any sense at all. Let's change by positive loopter. So change x by loopter x and change z by loopter z. That means we do need to flip what is in the if and else in these statements, where loopter z equals 1 and loopter x equals 1. So the zeros will be in the if part, and then the grid size -1 will be in the else. So that shouldn't make any difference to how it runs, it's working exactly the same. You'd love to see it. Now we should address the issue which came up in our 2D map, what happens when we get off the grid. So let's change the check chunk load block to limit the camera to be within the grid. I'm going to convert these if-elses to ifs with a stop the script inside of them. Then do the same for the other ones. And this is so all 4 cases can run. Now inside each of these cases, I'll get another if-else and I'll put everything here in the else. Note that we're only stopping the script in the else part. I'm going to check if chunk x is less than 1, and if it is, rather than changing chunk x, I will set camera x to chunk size. So we cannot go beyond the edge of the chunk. Now I'll do something similar for the other cases. Get an if-else. And then here we're going to need a slightly more complicated formula. We're going to multiply chunk x by chunk size, and then we're going to check if it's greater than the total size of the world, which is lattice count -1 times detail. So we're converting our chunk x and lattice count to the same sort of coordinates so that we can compare them. Now we'll do a similar thing in here, setting camera x to chunk size times 2. Now we'll do the same for the z. Duplicate this, replace what's in the else with what we have here in our camera z is less than chunk size, replace chunk x with chunk z, and camera x with camera z. Then finally for our last one, duplicate this code, replace what's in the else with what we have there, change the chunk x's to chunk z's and camera x to camera z. Alright, now we can try this out. Well, first we need to set our chunk x and chunk z to 0 when our flag is clicked, so we can easily test this. And you'll see that when we try to go off the world in this direction, we hit an invisible wall. Alright, lovely. Let's just set the spawn chunks to be back to 30 and 30. And there's one more feature I would like to add, and that is to have a sort of player. Now we can give the illusion of a player walking along the ground by simply setting our camera Y based on what height the terrain is at any given point. So go to move camera and let's get a find point height block here. So we'll want to find height at the camera's position. So find point height camera X camera Z. But we need to increase this based on what chunk we're in. So let's add to the camera X chunk X times chunk size. Then we'll divide this by detail, because this is sort of in our world coordinates rather than the coordinates that our Perlin noise uses. Now we'll duplicate this for the camera Z, changing chunk X to chunk Z. Then we'll set camera Y, and then we can just grab this height times detail over num layers we have in our draw terrain block. So that is the Y position of the surface of the terrain. Then let's just add 2 to it, so we're slightly above the terrain. Alright, I'll run this, and now we follow along the terrain. Okay, cool. So this gives us the illusion that we have like an actual player and stuff, even though it's just, the same old camera movement. Now when we go below the water, yeah, we don't see the terrain under the water at all. We just see, the water above us. So let's change that so we do actually render stuff under the water when we are underneath the water. In Draw Terrain, we want to draw both the terrain and the water. So I'll take out the first one here from the if height is greater than 0 in the if part. This is the terrain itself, the one that references the height. Then I'll move the second one to after we draw a point. Then duplicate our two other transform position blocks, and then draw point once more. Now these last 4 blocks are for the water. And let's only draw the water when our height is less than 0. So around those we'll put it if height is less than 0. Now around these, I only want to draw the terrain below the water if our camera is also below the water. So we can check if height is greater than 0 or camera Y is less than 0. So if we are below the water, we'll do it, or if the terrain is above the water, we will do it. Then remove the stuff inside of here and put this around our 4 other set transform position blocks. Move this outside. So we have 2 sets of transforming positions and drawing points. Hopefully you understand what I'm doing here. We're both drawing the terrain and drawing the water surface. Now for the water surface, rather than using the height variable here, I'm going to pass in 0. Because that is the height that we're drawing at. The water is at height 0. Now in Draw Point, I'm going to flip these around and check if height equals 0. And then put the water drawing in the if and this in the else. Then we can get one more if else, putting what we have in the else and checking if height is less than 0. So now rather than just 2 cases, we have 3. One is the water surface. One here that we haven't coded up is the part below the water, and then the last one, which is the default case, is the terrain that's above the water. Let's duplicate this part for this below the water stuff. I'll change this height less than 0.02 to height greater than negative 0.02. Now I'll switch this plus to a minus because now our height is negative, and then you can set the color to whatever you want, but I'll set it to a nice sandy yellow color. Alright, and let's run this and try going down into the water. And there you go. There is our sandiness. Our lovely under the water stuff. Okay, this is actually looking really cool. So we now have a player-ish thing, and we have a nice way of viewing the world. Gone are the days of being able to fly through and under terrain, and gone are the days of having a very small world. Now we can walk for miles. And it brings us to the end of this video. My next video will be a 3D Minecraft video, and we will be putting this terrain generation into the Minecraft game. But anyway, I hope you enjoyed this video. Have a great rest of your day, and goodbye!